morning and welcome back to the free educational webinar series brought to you by WeatherWorks. Today we'll be joined by WeatherWorks lead meteorologist Brad Miller, who you may recognize from our podcast, The Weather Lounge. Brad will be covering some information regarding late season weather events and discussing how snow and ice impacts can vary heading into the spring months. Brad, the floor is yours.
Thank you, Nate, and thanks for having me here hosting our March webinar. And again, we're going to talk about the impacts of late season snowfall. And once again, my name is Brad Miller. I'll be your host through this webinar today. And I've been with WeatherWorks since 2015. A little background about myself is before WeatherWorks, I was actually a television meteorologist at the CBS affiliate WCSC in Charleston, South Carolina. And I grew up in central New Jersey and lived in the Garden State till I was about 18 years old. So I know all about the northeastern winters, and I went through it for a long time before I actually moved down south. And also, as Nate did reference, I am one of the podcast managers of our podcast called The Weather Lounge, along with Mike Mahalik and Mike Priante. So that's it for me. Let's talk about what we're going to have here during our webinar, and a couple of points here. It's going to be the setup of the late season snow events, and also we're going to talk about the sun angle and how pavements react. Also, we'll visit a case study going back to April 15th and 16th, 2014. And then finally, at the end, we'll have a quick look at what's upcoming for this March weather pattern and whether or not we may see some late season snow. So let's get started here with a graph here, and you can see the average snowfall versus the maximum amount of snowfall that we've seen in March, basically along the I-95 corridor. And what catches your eye right there is Boston. Maximum amount of snow, 38.9 inches. Now, I don't know exactly what year that is. I may have to go back and check that out. But on average, Boston sees just under 10 inches of snow. But as you move south, Hartford, down towards Newark and Philadelphia, you notice not only does the average drop, but so does the maximum amount of snowfall that we have seen in the month of March, going all the way down to Richmond, which only averages about 1.5 inches each March. And the maximum amount there has been 8.3 inches in one past March year. And again, that's normally what we see with these late season months, or I guess late winter season months. And a lot of the snowfall that we get in March usually just comes from one or maybe two storms. It's not a usual average of several smaller events that we may see in January and February. And typical in March, we'll get like that one big storm that'll basically be 80 to 90% of your monthly snowfall. And that again holds true in a lot of the New England areas when you get some of these late season nor'easters. And as we go into April, dramatic drop, not only in the maximum snowfall, but even more so in the average snowfall. You can see Boston only averages 2.4 inches of snow in April, going down to basically a trace as you get into Baltimore and Richmond, and even the maximum amounts there in March are very low. Of course, catches your eye again, 22.4 inches in one April. Again, I'm not positive what year that was, but I'm sure it was probably one big nor'easter that brought with it a lot of snow, and that can happen. And again, going back to my days in central Jersey, I do remember growing up as a kid, a couple of white Easters. I remember a few big storms. Again, Easter, of course, can fall in late March or even into mid-April. So it happens. It's a kind of a thread the needle that we talk about, but it's not a guarantee. But when we do get a few snowstorms in March and April, they can add up pretty quickly. So here's our takeaways from our March and April climatology. It's quite rare to not see measurable snowfall in March and April in New England. This has only occurred once, though, in the past 15 years. And the maximums, of course, can be over 2 feet, and especially in March. In New Jersey, Pennsylvania, down towards the Hudson Valley, measurable snowfall lacked only 5 or 6 times in the last 15 years. So again, it does snow in March and April, obviously, less so as we get into April, but it's more likely that we'll see 1 inch or nothing at all. These are not minor events. Again, these are usually more of a big synoptic nor'easter storm versus as we get into clipper season and things like that, where it's more of a minor event there. As we get down towards Maryland and Delaware, more seasons than not have had measurable snow in the last 15 years, but that drops off considerably then as we, of course, head south into Virginia. And we saw that with Richmond, basically no snow in April, which again, you're getting down towards, almost the southeastern part of the United States by then. For the Midwest and Ohio, northern Illinois, you typically see 3 to 5 inches of snow on average, and the most of the last 10 years that have seen measurable snowfall amounts. In fact, the 10-year maximum is near a foot as you get out there towards the Midwest. So let's move on to sun angle, because that kind of goes hand in hand with March and April snowfall and the impacts that we actually see from the snow as we get into these later winter months. And basically, it's the angle from the horizon to where the sun is in the sky. The lower the sun is in the sky in the winter, and then it's higher, of course, in the summertime. Now, why is this important for snow accumulation? Well, when the sun is low in the sky, pavements don't receive a lot of energy to heat them up. So pavements are cooler, and that means pavement accumulation is easier. However, when the sun is higher in the sky, pavements receive more direct rays, more energy, and in turn, they heat up easier. So pavements are warmer, and that means pavement accumulation, of course, is harder to come by. Take a look at these equivalent sun angles. Now, basically what we're doing is we're comparing January 21st to November 21st, and the angle of the sun is about 30 degrees. It's a very low angle in the sky. It's not really, we're not getting much energy from the sun in these months, especially as we get towards Thanksgiving and then again late in January. So it's kind of the same sun angle, and that's our weakest amount of sun that we see is basically from November 1st all the way through the end of January. And the sun just, it's tough to warm things up. We don't see a lot of sun. Daylight's very short, but notice what happens as we get into February. The sun angle quickly increases up to 40 degrees above the horizon, and that matches up with October 21st. So basically your sun angle on February 21st is the same as October 21st. And we know in October we can still get warm days. Now let's move on one more month, March. And as we go into March 21st, first day of spring, September 21st is the same equivalent sun angle. That, of course, is the first day of fall. So we're kind of coming out of summer, going into fall, and coming out of winter, going into spring. Look at that sun angle, 50 degrees above the horizon. So that is a lot of sun. It heats up things really quickly, and basically the sun does its work as we get late March. And then by April, we're talking sun angles that are equivalent to late in August. Now, let me show you something here. This is our VeriFreeze product that we offer here at WeatherWorks, and kind of a neat scenario. We got two things to look at. Now, this is March, or I should say February 7th, just about a month ago, and this is in Mansfield, Massachusetts. Now, despite it being the first week of February, okay, we have snow on the ground, but notice the air temperature through the day, okay? Again, this is February the 7th, starting at 10 a.m. Notice the temperature never really gets above 26 or 27 degrees. Basically, it stays in the mid to upper 20s, the air temperature throughout the day. However, notice even with that sunshine, that pavement temperature gets above freezing for about 5 to 6 hours. That black line you see, that black horizontal line, that is the freezing mark. So again, pavements get above freezing for several hours, and in this case, when you have sunshine, you can get some snow cover to melt, despite the air temperature being well below freezing. Let's move on to another example here, February 26th. Now we're getting later into February. This is West Greenwich, Rhode Island. In this case, the air temperature actually gets just above the freezing marks. We're talking about highs maybe 33, 34 degrees, but for a long time with the sun out, notice that pavement temperature gets well above freezing. We're talking into the mid to even some upper 30s there. So again, even though it's late February, it's still in the dead of winter. We're getting a lot of sun, we're getting melting, and this plays a big role when we get into late winter impacts with snowstorms and snowfall, because despite the sun even being maybe behind the clouds, we still get warming through the clouds, and it can push that pavement temperature above freezing. So we need something else to help cool off the pavements when we do get some snowfall. And this is kind of what we fight as we go into March, and especially even more so into April. with the pavement temperatures. But once again, you notice as we go into nighttime, we lose the sun, pavement temperatures, and the air temperature quickly falls off. So again, this is part of our refreeze product that we do offer. I should say our VeriFreeze product that we do offer, but we talk about refreeze a lot as we get into February and March as well, because basically if we have a snowpack and that snow melts during the day like we see in these examples, and then it freezes up again at night, and that is something that we deal with a lot, and that can lead to some black ice, especially around snow piles. Maybe a lot of snow has melted throughout the day and you still have a 6 to 10-inch snowpack, and all that has to freeze up again. And you can notice here the air temperatures and the pavement temperatures falling below freezing at night, so by morning again we have that issue maybe with some black ice. So that's something that we fight a lot with refreeze and things like that as we go on through the late winter months. It also happens during the middle of winter too, but something that we're really we have to keep an eye on as we forecast right here at WeatherWorks. So let's talk about our two big questions here for late season snowfall. Biggest question: can it snow after a warm stretch or a warm rainy day? The answer is yes. And despite the previous warmth, if the air above us or aloft is cold enough, it can snow. It can snow at 44 to 45 degrees here at the surface, as long as the upper levels of the atmosphere are cold enough, or it's cold enough about a mile up or so. Usually snowflakes can make it all the way down to the ground. And that's something that we kind of look at. We call the 850 temperature. If it's 0 or below, can usually support snow all the way down to the surface. Again, that's a little more meteorological right there, but again, in these situations, the air closest to the surface or the boundary layer is warm, so usually rain can fall initially. However, if you get intensity to the rain, the colder air is kind of pulled down from aloft and will cool from top to bottom, basically from above down to the ground. So also this is something we call, we also mention a lot evaporational cooling or wet bulbing. Again, a little more of a meteorological term right there, but something you hear from time to time. So now the other question is, if it does snow, let's say it's snowing March 25th, can it accumulate? Well, a lot of times we know it can accumulate on grass and colder surfaces. You know, you get an inch or two on the car or, you know, on your back deck somewhere, but the pavements stay wet. However, there are instances though when it can cover up the pavement. And so we talk about snow melting on contact or accumulation on the relegated colder surfaces. But as we go on through a system or maybe a bigger snowstorm, okay, we talk and we ask ourselves, how cold will it be while it's snowing? Usually 32 degrees or below is ideal, but even 33 to 34, it is sufficient enough to maybe even accumulate on pavements, despite the air temperature being just a little bit above freezing. Then the other questions are, is it daytime or is it nighttime? Will there be sleet before the snow begins? And this is another big aspect to pavement accumulation late winter months, because sleet is more prone to accumulate above freezing or on marginal temperatures or on pavements that may be above freezing. And it also kind of acts like a primer. So if you can get like a layer of sleet with pavement temperatures 34, 35 degrees, snow that comes after the sleet can actually accumulate on top of that. So it kind of cools the surface enough to where you get that accumulation on the pavement. Also, are 1 inch per hour rates expected? Heavy snow can almost always overcome melting. We've seen instances of this even with snow squalls. We can remember a few times, even in March, you may get a snow squall that comes through, and granted, it might have been 38, 39 degrees before the squall comes through, and quickly the pavements can cover up when you get that real fast burst of snow. And then before you know it though, after it covers, it melts back. But if you get an ongoing system with a lot of heavy snow, then pavements can continue to accumulate even during the daytime. And the last question is, are higher elevations involved in any kind of a storm? So let's move on to a case study. We're going well into April here, and we're talking April 15th to 16th, 2014. I was down south, but I'm sure a lot of folks may remember this system. It wasn't a huge system, but it was very, I guess, neat to watch unfold as we went on through the nighttime. Now, to the right, that is Newark, New Jersey, daytime maximum and minimum, basically high and low temperature for the first 15 days of April. And not one temperature at night went to freezing. The lowest you can find there is actually 33. That was the night of this system. But before that, It never even got below 35 degrees. And look at the high temperatures. We were in the 50s and 60s for the first week of April, and then check out April 13th and 14th, a couple of days before this system moved in. It was in the 80s. So you're thinking, all right, well, we can't snow anymore. There's no possible way pavements can cover. Well, what happened was a very strong cold front came through the night of April 15th to the 16th. It provided some brief snow and sleet, but believe it or not, pavements did cover. And you can see how things progressed. Now, if you look at the bottom of this little hour to hour weather update here from Newark, this is what we call their METAR, or their hourly weather observations. And if we start here at 3:51 p.m. in the afternoon, you can see the temperature was 66 degrees. Okay. Now, as you move in through time, we're going up the chart here, or up the page here. That's going forward in time. Notice how the rain begins, temperatures start to fall, and still, even at 10 o'clock at night, we're at 39 degrees. Yeah, it's getting cold. It's raining. You're thinking, all right, well, it's not going to do much here, But notice the little PL mixed in with the RA. That means there's pellets or sleet beginning to mix in with the rain. Now, as it continues to precipitate, temperatures continue to fall. And not only that, I want you to notice there at the right, heavy precipitation starts to really fall. And we're talking about rainfall rates or precipitation rates of 0.1 to 0.15 per hour. If this was all snow, you'd be basically getting 1 to 2 inches of snow per hour. But in this case, we're kind of getting a mix of rain and sleet and snow, and it's cooling the atmosphere. And what's happening now is, at the same time, it's coming down heavier and heavier. You got sleet mixed in. And again, we talked about this earlier. It's kind of priming the pavement a bit. So despite we had temperatures in the 80s just 48 hours ago, we're getting a mix of rain, sleet, and snow. And what happens is we look at the radar. And this is from 10:30 that night. And even though there's what you're basically looking at is the oval right there is New York City going up into the Hudson Valley, Newark, and kind of getting into the New Jersey shoreline. And notice how there's some really heavier returns on the radar, and more so to the south, coming up the coast there of New Jersey. And that's going to go right over that area over the next couple of hours. Meanwhile, the elevations, while they are colder, they're not really getting the heavier precipitation amount here, or the radar returns going over them. So they're kind of staying as a mix of rain and snow. It's probably not going to do much on pavements. It may just accumulate on grassy surfaces and things like that. But once again, let's go back to this and notice here as we go between 10 o'clock and about 1 a.m., not only does visibility drop to 1 to 2 miles in this mix of rain, sleet, and snow, we got the heavier QPF, or what we call quantitative precipitation values or amounts for that couple of hours. And we are seeing that changeover now to snow. So by 12:30, it's just all snow, and it's coming down heavily. And at the same time, it's beginning now to coat up the pavements. And we're seeing accumulations not only on just cars and grasses, we're starting to see it on roadways and sidewalks and things like that. And now, mind you, it is the middle of the night. We have no sun angle, no sun at all, and pavements have now cooled enough, and we're going to continue to accumulate until the precipitation ends. And notice, though, once the precipitation does move out after 1 o'clock, it's still snow, it's still sleet, but the temperature starts to come back up. But within that 2 to 3 hour time frame, we had pavement accumulation in the middle of April in Newark after temperatures were in the 80s just about 48 hours ago. So here's a quick look at the storm totals from that system. And usually, you get the higher elevations, you get a little bit, you got the Catskills in there, a couple inches of snow, you got the higher ups of northwestern Connecticut, Litchfield, and going up even into the Berkshires. But notice that one oval right there from the lower Hudson Valley right through New York City and Newark, and even into Monmouth County into New Jersey. The highest accumulations were occurring right here with pavement coverings, and this coincided with that heaviest band of precipitation. So once again, the heaviest precip, snow and sleet, it changed. It allowed for these pavements to again cover. Where it was lighter, pavements probably just stayed wet everywhere until you got maybe to the very highest elevations of Catskills and things like that. So overall, here's what we're looking at. Warm season snow is fairly common each year. Any accumulation is typically confined to colder surfaces. However, we have seen examples where pavements cover as well. Necessary ingredients are often temperatures cooling to 32 to 34 or less. Heavy snowfall off of 1 inch per hour. We looked at that. QPF, or precipitation amounts, liquid amounts of 0.1 to 0.2. That's what it equates to. Nighttime will significantly increase that pavement threat, of course, and this is often accomplished through banding that we looked at on the radar, or just even the influence of elevation. But in the case study that we looked at, it was basically just due to the banding and the heavier returns on radar. Sleet can aid in the accumulation process in this case as well, especially if it does precede that snowfall. So a couple of end of session questions. Let's look at, maybe again, what we learned here. Which one of these are nearly always present in warm season pavement accumulation snow events? Temperatures below 32, visibility below a half mile, or liquid rates of 0.1 or 0.1 per hour or greater? The answer is liquid rates have to be above a tenth of an inch an hour or greater. Of course, the visibility, you could still snow at a mile if it's 35 degrees. It's not going to do anything on pavement. But once you get that accumulation rate, and it's really starting to band in certain areas, that's when you can get that pavement accumulation. And again, even sometimes during the day, if it's heavy enough. All right, next question. When pavements accumulate in the warm season, it is often A, widespread due to a large scale storm, B, localized from intense banding, or C, only in elevated locations and away from the coast. B, again, we've seen this on the radar, localized from intense banding. And while elevations and locations away from the coast are most prone to warm season accumulation, pavement accumulation is very localized. And once again, right over where that heaviest band set up, that's where we saw the pavement accumulation. East and west of there, where precipitation was lighter, nothing on pavement. You wake up, you see an inch of snow on grass, but nothing again to worry about on pavements where it was warm enough. So a large scale storm though may produce some mixing through the region, but accumulation only occurs within the banding structures. So additionally, the odds of pavement accumulation, of course, are much greater than at night. Last question. Let's say it has been snowing or mixing kind of through the afternoon with no accumulation, been 36, 37 degrees, kind of white rain as we call it, just melts on contact with everything. But let's assume sunsets at 7:02 and it continues to precipitate and mix and snow as we go on through the evening. At what time does the threat for pavement accumulation begin to significantly increase? Is it 5, 7, or 8 p.m.? Well, believe it or not, it's the earliest time at 5 p.m. Granted, it's still daytime, it's still daylight, but as we get closer and closer to sunset, despite it being in the warmer season, snow won't really accumulate like we said during the day. But as we get closer to sunset, and just a couple of hours before that, that's when we can start to see even some pavements start to coat up on the sides. And then when we get past sunset, if it continues to snow or mix, it kind of encroaches towards the center. And before you know it, maybe the entire pavement or the entire sidewalk or entire parking lot has covered over, and then you got to start with doing some salting at least. So, things that we are always watching here for in the late season at WeatherWorks in our forecasts. All right, lastly, let's look at what may happen here for this month of March. And, it's been kind of an up and down winter. We actually had a pretty cold January. February was kind of a roller coaster ride, warm here, cold here, a couple of snow events mixed in, ice events, of course. March kind of is going to be the same idea, but there may be enough of a cold lobe there, you see, just over eastern Canada, and there may be just enough of a trough that we kind of get what we call a split flow when we get the southern and northern jets to kind of come together. Now, as we get further into March, it turns into what we call more of a thread the needle. You kind of need everything to come together just right to get an East Coast snowstorm. Of course, New England has the best chance for any kind of snow and maybe significant storms up that way. As you get further down towards mid-Atlantic, your chances, of course, decrease as you go on through the month. But, again, if we get just the right setup where we have cold air kind of in place already, and you get that coastal system to come up the coast, we have that chance for a significant snowfall, hence a nor'easter. One that particularly comes to mind for me was the superstorm way back in 1993. That was in the middle of March, but that just about crushed the entire East Coast. And we're talking from Maine all the way down to northern Georgia, where snowfall amounts were in the feet, 2, 3, 4 feet of snow. I think Mount Mitchell in North Carolina had like 5 feet of snow. So it can happen, obviously. You don't even need the best of patterns. You just need that right setup. And that's kind of what we look for in March. But in this case, yeah, the chances there, obviously, and we'll just have to watch how we progress on through the month. But, with that little bit of cold air lingering or hanging on nearby, we could see, a nor'easter or two, but we'll just have to see how that all plays out. Well, that will just about do it for our webinar today. And thank you very much for tuning in and listening to me rant here about impacts of late season snow and, kind of what we watch for in March and April. We're always here from you. Again, we are WeatherWorks. We're located in Hackettstown, New Jersey. Our website is weatherworksinc.com. And feel free to send me an email, bradmiller@weatherworksinc.com also. And you can find us on every social media platform, Facebook, Twitter, Instagram, we're there. And also don't forget to check out our podcast again, myself, Mike, and Mike Priante. We have a podcast every 2 weeks, and that's called The Weather Lounge. And again, you can find that on just about any other place you find all your other podcasts. So again, thank you very much for allowing me to host. And Nate, I'll send it back to you.
Yeah, thank you, Brad, for the presentation, and thank you to all that joined us today. We wish you all the best as we close out the 2021-22 winter season, and hope to have you back for our upcoming webinars this spring and summer. So thank you all again, and take care.